We just finished talking about the different theories of intelligence and spent some time talking about the development of the Stanford Binet. So in this second part, I want to talk about some more theories. Focus mainly on the Wechsler intelligence scale, how that was developed. All right, so 1939, so this starts. There's this Wechsler scale. It's developed to directly compete with the Binet version. So 2 years after the 1937 Binet revision, the first Wechsler test is published, the Wechsler-Bellevue intelligence scale. So here are the criticisms of Binet. So because intelligence is multifaceted and the Binet scale only produced at that point a single IQ score, people weren't happy with that. And the 1937 Binet was developed for children, right? That was the limited standardization sample they had was really on children, but they claimed to also test adult intelligence. The 1937 Binet has an overemphasis on speeded timed tasks, which is more difficult for older adults. And intelligence can decline as one ages, and the 1937 Binet does not account for this. All right, so these are the main criticisms of the current form of the Stanford Binet scale in 1937. So in 1939, we saw the Wechsler-Bellevue scale was developed. All right. So advantages of the 1939 Wechsler-Bellevue. There's an age scale versus point scale. The 1937 Binet scale used an age scale. Scores on a particular test are based on basal and ceiling levels. Each basal or ceiling level had a chronological age associated with items at that level. So a person who successfully completed 3 out of 4 items at the 6-year-old level would have a basal mental age of 6 years. Okay, that's sort of how the Binet scale sort of worked. Content of items at each level of the age scales could vary tremendously. Vocabulary word, arithmetic problem, and digit repetition, for example, could all be asked sequentially at a given age level of the 1937 Binet scale. So the 1939 Wechsler-Bellevue used a point scale instead of an age scale. Items in the scale answered correctly are each given a certain number of points, so they're likely associated with difficulty. If you answered more difficult points, you actually got more. You were awarded more points for them, where that was not true, I believe, for the Binet scale. And point scales allow for more homogeneous content. So because they use the point scales allow, again, for more homogeneous content. As such, Wechsler could obtain scores for an individual in a wide range of content areas, like vocabulary, creative thinking, judgment, general knowledge. They didn't have to only fall in the specific scale that they were created for. Because there were points, you can just simply add points up. It was harder to do when you're trying to combine age scores together. It made it more complex. So this made it a little more easy, a little easier, a little more flexible. And the Wechsler-Bellevue included a performance scale. So Binet was criticized for its over-reliance on verbal skills to measure IQ, and I mentioned that before, and you can see why later the Stanford Binet started including more non-verbal tasks. Okay, so 1939, Wechsler started with that idea as a solution for that, where there was a bunch of nonverbal scales that they called performance scales. It was things that you did, performed, as opposed to responded to verbally or read or wrote down. Okay. The normative sample for 1939 Wechsler-Bellevue, it's probably not super surprising. A lot of this stuff is over 1,000 white respondents from Eastern U.S., primarily New York. Again, it's an over-reliance upon the convenience samples from the area more than likely than, it's potentially, I guess, it was more nefarious than that, but I'm going to try to be optimistic and believe it was just for convenience, which is still not good. The first revision in 1955 is where we first saw, I went from the Wechsler-Bellevue to what's known now as the WAIS, the Wechsler Adult Intelligence Scale. There was a second revision in 1981 where it became the WAIS revised, the WAIS-R. There's a third revision in 1997 which became the WAIS-III the Wechsler, the third edition, and the standardization sample here is based on close to 2,500 adults in 13 age groups, and were stratified to according to 1995 census data. So what that means is they looked at the census data for the proportions of a variety of people, and they tried to then make the sample match those strata. So let's say at that time there was 20% Hispanic or something in an area, that would try to make sure that that strata was represented at that proportion. So it was a way of sort of making sure that the standardization sample was more representative of the people in the area at that time. Okay. Other test versions, instead of having just one test, they had the Wechsler Adult Intelligence Scale, and they developed a separate one, which is the Wechsler Intelligence Scale for children. So the Stanford Binet was really just one test that was supposed to adapt to being used for children and for adults, and here they just made two different tests. Here's a test for children, here's a test for adults. So the WAIS was for ages 6 to 16. The WAIS was originally developed as a downward extension of the Wechsler Adult Intelligence Scale in 1949, a revised edition in 1974, and there was an accompanying 1991 revision, and there's a current 2003 version that is, again, it may have been updated since then. I don't have it in here, but the current version of the WAIS-IV is what it was, at least at this point. Then they also had the Wechsler Preschool and Primary Scale of Intelligence. All right, so now we're talking about 3 different tests that were designed to target, now here's, preschool and primary school, a separate test for 6 to 16-year-olds, and then another test for adults, which seems to make a lot more sense. So instead of having this adaptive approach where everyone starts off in the same way and then sort of gets routed, let's just say, look, let's just have 3 different tests. All right, so originally developed in 1967 as a descendant of the WAIS and the WISC, has been revised twice in 89 and 2002. The current version, at least according to this, is the Wechsler Preschool and Primary School and Test Scale of Intelligence, the third edition, provides subtests and composite scores that represent intellectual functioning and verbal and performance cognitive domains, as well as a composite score that does what they call the full scale IQ. Okay, so this idea of a full scale IQ is sort of synonymous, but I'm fairly certain the idea of full scale that splits up verbal and nonverbal came from the Wechsler, and later the Stanford Binet adapted to that because they wanted to remain sort of competitive with the Wechsler test. They even have pronounced like the WASI, the Wechsler Abbreviated Scale of Intelligence, because in 1997, when they were revising the WAIS, they took developed a shorter 4 subtest version of the battery that was released at that point, allowing clinicians to form a validated estimate of verbal performance and full scale IQ in a shorter amount of time. Because all these tests do, because they're administered, they take a while to deliver, and it's time consuming and stuff, especially if you have a lot of clients you're working with. So this was developed to be a shorter version to get you a pretty good idea of what their intelligence looks like. Uses vocabulary similarities, block design, and matrix reasoning subtests similar to those of the WAIS to provide an estimate of that full scale IQ, but only takes 30 minutes. So it takes less time than the original. So this is the WAIS, the Adult Intelligence Verbal Scale. There are subtests for vocabulary similarities, arithmetic, digit span, information comprehension, and letter numbering sequences. So this is sort of what it taps into. Like the letter numbering sequences tap into concentration and working memory. Information really taps into knowledge, which when you think about the original Stanford Binet test, when you're looking at, okay, well, what does your average 10-year-old know, and do you know that much? This really gets back at the original idea of what it is, what do you know at different ages, and that gets into the sort of wealth or fund of knowledge. The arithmetic, looks at concentration and working memory. Digit span, again, is being able to remember spans of digits. It looks at working memory, stuff like that. The performance subtests. Now, look, they had picture completion, they had digit symbol coding, block design, matrix reasoning, picture arrangement, symbol search, object assembly. right? So these are looking at all kinds of other skills that aren't directly tied to verbal, to linguistic or verbal mastery. So if you look at like block design, that's similar to what you saw in the Stanford Binet later, where they would give them some blocks arranged in a certain way, and then the person had to sort of recreate the design with the blocks, being able to find symbols and be able to. It looks at speed of processing. Picture arrangement, you're given a set of pictures and you have to put them in an order that makes sense as a sequence of events, so to get at sort of the understanding of social reasoning and sort of planning ability and those sorts of things. So I mentioned most of those, but we're going to go through them in a little more detail. But so vocabulary, you give a word, ask for definition. Very simple. Taps knowledge of words and their meaning. Good measure of what they call pre-morbid functioning, like intellectual capacity prior to trauma or illness. As brain damage continues, vocabulary is one of the last test scores to be affected, which is interesting. And it's a very stable measure of intelligence. So this is one of the ones that are going to have a higher reliability because it stays fairly stable even across ages and things. Similarities, you present two words and ask how they are alike. So this is, similar to like an analogies test on the SATs or something. Early items tap previously learned associations, like how are a dog and a cat alike. Later items require abstract thinking, like how are liberty and freedom alike. Can also be used to find serious psychopathology, like idiosyncratic reasoning. If you ask how a dog or cat are alike or something like that, and their answer is sort of something out there, you can sort of get at that they have a very strange reasoning, like, I don't know, because we're talking about psychopathology, especially with something like antisocial behavior, I don't know, but how a dog and cats are like, well, they both bleed the same or something, get some, really morbid answers that might sort of lead you down the idea that there's some kind of psychopathology there, depending on how they see the similarities. Again, arithmetic is fairly straightforward, frequently thought to be a math test. But there's little math involved. It's more of a test of active working memory. If envelopes are 25 cents a dozen and you buy 3 dozen envelopes, how much change would you get back from $1? So not only is this, testing sort of a little bit of math ability, but it's really getting at this idea of working memory. Can you keep all the information in your brain while trying to figure out the problem? And also just, it's getting at least in this way, they put it in a context, it's a fairly regular event, like going and buying things from a store, getting change, and sort of tests for those things and sees that they're there. So subject to effects of anxiety, depression, as well as cognitive deficits. Interesting, you think, okay, cognitive deficits I get, but anxiety and depression seem like they would be unrelated. But I think the idea here is that anxiety and depression can be things that detract from active working memory, because if you're like anxious, for instance, and you're have a constant loop in there of sort of worry about things, it's taking away from the resources you have to sort of keep things in memory and work them out. Digit span, numbers presented, 1 per second to a subject. Subject asked them to repeat the digits forward and reversed, just like with Stanford Binet. You can kind of see, even though I'm talking about this second, that the Stanford Binet started to adopt or steal a lot of the components that were in the Wechsler to try and remain competitive. There are separate scores obtained for digits forward and backwards, but again, they're combined when reported for this particular subtest. Taps active working memory, concentration, short-term auditory memory, all those things. It's also subject to anxiety, depression, and other forms of psychopathology. Again, anything that has working memory, things that tend to flood our working memory. Again, anxiety has a tendency to do that, will limit the capacity for your working memory to do its thing, and therefore you'll tend to do worse on some of these kinds of items. Information, ask a question about general knowledge, and the subject gives an answer. Task general fund of knowledge, also curiosity, academic achievement, and the effects of enriched environment. Like, how many senators come from each state in the United States? So again, this goes back to this at least original idea of mental age, where do you know as much as someone your age or other people your age know, right? So this is getting at sort of general knowledge type questions. for comprehension, it asks 3 different types of questions. Appropriate responses to hypothetical situations, like what is the thing you do if you see someone lying in the street? Right, so you can get at, this is almost getting in a more open-ended, like thematic apperception type of thing, where they're given a scenario and ask, what they should do or what led up to that scenario. Logical explanations for everyday actions, like why do we elect senators? Proverb interpretations, like what does a stitch in time saves 9 mean? So do they really, go to a more literal interpretation, or do they actually sort of get at the more the meaning behind what that sort of phrase means? And this also gives an idea of why it's important that these scales get updated every once in a while, because certain proverbs or colloquialisms like this, they start to sometimes fade out, and people may not know what this stuff means. Like, do you know what a stitch in time saves 9 means? Have you ever heard that proverb before? It's possible you may not have. There's lots of those sort of things, like what does it mean? Why do people say not to look a gift horse in the mouth? And now we know that the phrase means something like, if someone gives you something, does something for you, you shouldn't complain, right? Don't look a gift horse in the mouth. If someone does something for you, even if it doesn't come out perfect or the way it's supposed to, you really shouldn't complain about it. You should be thankful and grateful for the fact they did a thing for you, even if it wasn't quite what you wanted. And the sort of more literal interpretation of that, and with the gift horse in the mouth, and something that I bring up because I remember I had a long conversation with my wife, I think when we were dating a long time ago. That came up, and we started thinking about what that means, and I realized I had never really thought about that phrase and where it comes from. This idea that you can tell the age of a horse. I don't know how this is, but you can tell the age of a horse by looking at the horse's teeth somehow. So people oftentimes will check, like if you're a veterinarian or something like that, you'll check for the age of a horse by looking at its mouth. So the idea is, if someone gives you a horse for free, you shouldn't right away go, well, how old is this horse? And sort of complain that they're giving you some old horse that's not very useful. So not to look a gift horse in the mouth is something that people say, but it's a strange proverb, colloquialism that we use. This stitch in time saves 9 comes from like sewing or knitting or something, and it's this idea that if you catch a stitch at the right time, one stitch can save you from having to go back and redo other stitches that you had already completed. So a stitch in time saves 9 is a proverb supposed to be like, well, if the idea of doing something at the appropriate time can save you a lot of pain and anguish or suffering or something like that on down the road, like having to re-stitch something or re-sew something. Anyway, I probably don't have that perfectly right, but it's something somewhere along those lines. So this taps into sort of social and moral reasoning, conventional knowledge as well, and also provides an arena for idiosyncratic responses, right? So again, looking at psychopathology or things like dementia or other cognitive impairments, asking these kinds of questions seem like they would be straightforward, but if you have something like that, some kind of pathology like that, it's going to come across very stark, in a very stark way when asking these types of questions. Okay. Letter and number sequencing. This goes beyond just a sort of digit span, where you're now looking at this is sort of an optional subtest, not required to compute verbal IQ scores. It's one of the newest subtests. You present a sequence of letters and numbers, and subject has to sort them into a sequential order. So the stimulus here is like Z3, B, 1, 2A, and you're supposed to put them in order, 1, 2, 3, ABC, A, B, Z. Taps active working memory sequential processing, also subject to psychopathology effects. Being able to sort of, it might affect the way that you sort them if you have different beliefs about letters and numbers and things due to some kind of psychopathology. If you want to score the sort of verbal subtests, raw scores on each test are converted to scaled scores. Each scaled score has a mean of 10, summation of 3. And you get two sets of scaled scores, an age-adjusted norms, like ability to compare to other individuals in the same normative sample. This allows for peer comparison, but not cross-age contrast. So that means that if you can actually compare yourself with other people in the same age range, but because they're scaled differently, you can't really compare IQs across ages very well. And then you got reference group norms, which ability to compare to a group of individuals in the normative sample between the ages of 20 and 34, and this allows a better contrast across ages, but isn't quite probably as sensitive within an age group. Age-adjusted scores are then summed, except for the optional subtest. And this sum is compared with the standardization sample for all age groups. And like if people do ANOVAs and things, they do not show significant age effects on any IQ or index. And the resulting score is the verbal IQ. And again, it has a fixed mean of 100, standardization of 15, and that's how you get the verbal. And then a similar process goes for the performance subtest. So let's talk about those. You got picture completion. So you show a picture with an important detail missing. And in 20 seconds, subject has to come up with the missing detail. And this taps into, to detail scanning and just sort of understanding of scenarios and those sorts of things. Digit symbol coding, presenting an array of numbers with matched abstract symbols as a key. Multiple empty boxes with numbers below. Complete as many as possible numbered boxes with appropriate key in 120 seconds. You've probably seen these kinds of things. They pop up even on like social media, where they'll be like, they'll show you like 3 symbols and it equals 30, and then another symbol, and then so you're getting at this idea of, can you translate digits, numbers to symbols, and be able to use them as use the symbols to sort of solve problems or complete sequences. Okay. Block design. I mentioned this before. Present an array of blocks on a card. Right, so show the subject that has some blocks in making a design, and then they have a certain time. They have to then take some actual blocks and make the design. Task visual motor skills, processing speed. The input is visual because you look at the card, and then the output is sort of motor. You got to actually manipulate things. It's the best test of non-verbal concept formation and abstract thinking on the WAIS. Matrix reasoning. This is like a new to the WAIS-III, but similar to the Binet matrix reasoning test. Present subject with a non-verbal sequence of matrices. Subject must produce the content of the missing cell. So again, this is like, there's some kind of matrix of patterns of things. And based on what the symbols and things or whatever is in the matrix looks like, there's a missing cell. You have to come up with, okay, well, what's the thing that's supposed to go in the missing cell? It taps nonverbal logic, abstract reasoning, inductive reasoning skills, fluid intelligence, all those things at the same time. You got picture arrangement, which is sort of similar. So you're presented with an array of pictures similar to a comic strip, right? But scrambled in order. This is also similar to, there's even games nowadays. Same thing, you're actually asked to make like a 3-card sequence, and then whoever makes the best 3-card sequence actually wins the round. It's sort of similar to something like Cards Against Humanity or something, where everyone has a certain amount of cards and you have to sort of, but instead of responding to a prompt, you're given a picture and you have to, from that picture, using your own cards, make the best cartoons. From Cyanide and Happiness is the comic strip, they made a game. So it's a similar idea. You're supposed to put pictures into a sequence to make a story. Subject's asked to arrange the pictures in an order that makes sense, which is very general, as quickly as possible. And the shorter time it takes you, the more points you get. It taps social reasoning, nonverbal reasoning, sequential reasoning, and then also it gets into cause and effect relationships, because the stories oftentimes have indications of things that are going on, and you can actually, if you put the cause and effect in sort of the right order, then you understand cause and effect relationships. You got object assembly, present subject with a sort of puzzle, like pieces, things that are manipulative, and subject is to arrange the puzzle in as short as time as possible. Like it's just, puzzle completion. Taps knowledge of part-whole relationships, visual motor reasoning skills, those types of things. You got symbol search. It's also new in the sort of WAIS-III. appeared in the WAIS-III earlier than that, but it didn't get into the adult version until the 3. It's an optional subtest. The subject is shown 2 target abstract symbols and is asked to determine if either target symbol appears in a set of distractor symbols. So you're shown, a couple of symbols, and then you're shown a bunch of other symbols, and you're asked to see if you can find, literally search for the symbol in these other distractors. And you can do as many as, try to do as many as possible in 120 seconds. Shorter times, more correct equals sort of higher scores. It taps visual discrimination, processing speed. And again, these are things that you might see pop up on a social media page where, it'd be a bunch of symbols and it's like, how fast can you find this symbol? And you're going to go through, or if you've seen one where it's like a bunch of, it's like a picture of a bunch of dogs or bears or something like that, and you had to find the panda, the one sort of different one. And I guess in some ways it sort of goes back to being similar to Where's Waldo, right? Having a bunch of distractions and being able to try to find the thing you're looking for in a set of other similar symbols. All right, so what do we do with the performance subtests? So age-adjusted scores are then summed, again, not the optional test. And this sum is compared with the standardization sample for all age groups. And again, it doesn't seem there's a whole lot of significant differences depending on this because of the age norming. And the resulting scores is the performance IQ. So you get instead of getting in like the Stanford Binet verbal and non-verbal IQ, you get a verbal and performance IQ. And again, this is standardized to have a mean standardization 15. So you're really getting an IQ score for verbal and IQ score for performance, and then they're combined together to give you what they call the full scale IQ. So age-corrected scaled scores for non-optional subtests are summed, and this sum is used to produce the full scale IQ. And again, it also has a mean of 100 standardization 15. Okay. Now, this is another thing that's interesting too. Is the WAIS also has what they call sort of index scores. So aside from verbal, performance, and full scale, the WAIS-III provides for 4 additional measures of ability. So you can actually get scores for verbal comprehension, perceptual organization, working memory. Sometimes they call this freedom from distractibility, and then also a score for processing speed. So these are different, not subtests, but they call them index scores. They're different scores that you can get by recombining items within the test to give you these scores on these areas. So verbal comprehension combines vocabulary, similarities, information. It's a sort of a pure measure of verbal abilities. Has no working memory component or attention-related concerns. And this measures more crystallized intelligence, right? So your ability to recall vocabulary, to understand similarities, and to be able to sort of regurgitate information. This is all things that really isn't about fluid. It's not about sort of reasoning or adapting. It's the stuff that you know. So it's more crystallized. Perceptual organization is picture completion plus block design plus matrix reasoning, and this really measures fluid intelligence. Also loads on attention to details and visual and motor integration. So it gives you an indication of all kinds of information about the respondent. Then you have a working memory. It's more or less straightforward. You got the arithmetic, and digit span, letter number sequencing. On WAIS-III, without letter number sequences, the same index score is called freedom from distractibility, which is why I mentioned it here. So it's similar. The WAIS it's called working memory, but for the kids they call it freedom from distractibility. Measures active working memory, and the processing speed index score is putting together the digit, symbol coding, and symbol search. Because they really get at how quickly can you take something like a symbol or whatever and process information and be able to find the symbol, or to have that symbol sort of reflect a digit in a sequence. So it really gets that sort of your processing speed for things like symbols. So interpreting, the scale can be sort of rough. So Wechsler Adult Intelligence Scale 3rd edition, you got verbal subtests, performance subtests, and you can see the sort of different scores that are possible on each one. You can sort of add them up. So if you were to try to score all these, I'm not going to even attempted, but if you were to score these things in a way they get because these are all so you can add up the verbal subtests, add up the performance subtests to give you the verbal and performance IQ. You can then use those to rescale to the full scale IQ, and then if you recombine based on the stuff we just talked about, these index scores, you can then get their verbal comprehension, perceptual organization, working memory, and processing speed scores by simply recombining the scores from those subtests together. Okay. So interpreting the WAIS-III, a little more is So step one is interpret the full scale IQ. Step two is you then try to interpret the verbal IQ and performance IQs and note discrepancies. So here there's not a whole lot. All right, so look at the full scale. There are 111. The verbal IQ is like 1 point lower, but it doesn't seem to be super alarming. But we look at it as a full scale IQ. If one of these other scales is sort of lower, by some margin, I'm not sure what, it might give you an indication of sort of where a person's strengths or weaknesses might be. You can interpret index scores, interpret the subtest scaled scores, and note any discrepancies. Analyses and patterns of the WAIS scores have not produced reliable findings, meaning that depending, each time it's been done, they're getting different results, different information. So it's better to use these discrepancies to generate hypotheses than it is to really make any conclusions from them. But anyway, so, you can go through and start from the top down, interpret the full scale, and start to notice discrepancy between that and the verbal and performance IQ. Interpret the index scores, and then look at the subtests and see how they differ from the index scores to really start to look at what might be going on with that respondent. So, again, look at the full scale IQ. Did I go backwards or did I go forward? So, again, there's not a whole lot of discrepancies here. If you look at the processing speed index is on the lower end, right, compared to the other two. So it seems like that, that's a place where that could be problematic. But perceptual organization seems to be this person's strength. They may be driving a lot of their ability to sort of do these other subscales on the full scale IQ. So the psychometrics here, reliability, the split half coefficient without the speeded tasks. Full scale IQ is 0.98, 0.97 for verbal, and 0.94 for performance. All really good. Test retest seems higher for full scale than it was for reliability, at least consistently, because they had with Stanford Binet they had some test retests that were down like in the sevens, right? So it seems like maybe it's higher. Verbal IQ is high. Performance IQ is a little bit lower, but still within an acceptable range. And I wonder if that's a bit of that's because just variability in things like speed and other stuff that sometimes people might be able to do things faster or slower. That's going to affect the reliability because the scoring is based on the speed, right? So recall the standard error of measurement can be calculated using this whole thing, like 1 minus the reliability times the standard deviation. As such, we can describe the 95% a score plus 2 standard errors of mean, and 99% confidence intervals for each of those IQ scores. We can use this to sort of take a guess at what that might look like. So if you were to follow this, right, to get measures at the 95th percentile by using the standard error that we could figure out from the reliability, we then figure out, you can actually give someone, so a person's score is 108, and you can figure out that their confidence interval around that score is somewhere between 105.58 and 110.42. So suppose someone's measured with WAIS-III and a full scale IQ of 108, you can figure out what is the 95% confidence interval around that test score. Here's why this is important, because you realize that as people take IQ, there's going to be a range and there's error. So instead of just saying your IQ is 108, we can say, well, your IQ is likely to range somewhere between 105.58 and 110.42, and give them sort of more information about where their intelligence seems to lie, right? Based on just knowing the standard error. The subtest reliabilities are generally too low to be psychometrically sound, which is weird. So there's all these subtests, and when you sort of put them all together, they seem to represent a reliable construct, but on their own, not so much. So most of them are in the 70s and the 0.7, the 0.8s, but with a few in 0.6s. As such, scores on the subtests are likely to bounce around more than on the IQ scales and index scales. And again, because the more items and more things are being combined together to give you like the verbal or performance scales, it's going to add to the sort of consistency a little bit. As there are fewer items on just one of these subtests, people, if you do better or worse on just a couple of them, it's going to change your score a bit, and it's going to cause you to bounce around and be less reliable. This makes profile analysis sort of impossible from a psychometric perspective. You might be thinking, profile analysis, what are you talking about? Well, if we'll talk about this more, we talk about like the MMPI, we start to look at a profile across subtests to really look at sort of diagnostically what's going on with people in terms of looking at peaks and valleys and things in their scoring. And that's sort of because these sort of bounce around and not as reliable, they tend not to use those subtests too seriously. It's really the verbal full scale and some of the other not subtests but the index scores more than they ever do any of the subtests on their own. Okay. Generally, looking at the validity of the WAIS. Correlations with the older WAIS-R and for small groups of subjects, the WAIS-III, the validity coefficients are a little bit all over the place, range between 0.5 to 0.9 for the subtests. But for verbal IQ, performance, and full scale, looking at the older versions, and I imagine if you looked at other versions of other types of intelligence scales, this would hold up pretty well. The WAIS has actually been, the Stanford Binet and WAIS have been the two probably the most widely used intelligence scores. When someone talks about their IQ score, it's likely to have come from some version of the Wechsler or some version of the Stanford Binet. So I imagine they've been around this long and stuck around because they have fairly decent reliability and validity for what they're talking about. So in terms of evaluation, the WAIS-III considers more than one type of intelligence, but clearly not the kind of multiple intelligence which Howard Gardner speaks. I said Michael Gardner, that's an instructor in the department. Howard Gardner, so even though we're working towards this idea of having more intelligences, none of them actually match this idea of this like multiple sort of 8 intelligences that are talked about by Gardner, but at least it's getting closer. We're looking at the fluid versus crystallized, and the competitiveness. It's like with anything, and I guess this really like gets into this belief in sort of capitalism or whatever, that if there was no competitor to the Stanford Binet, it was sort of allowed to be the only game in town for intelligence, they likely never would have innovated or changed. It would have been the same thing going forward. One of the big gains that the Wechsler-Bellevue scale sort of did was to push the only sort of intelligence scale in town in a more inclusive, complex assessment of intelligence while doing it themselves. But they both came at the end to have a much more varied and more informative way of looking at intelligence that wouldn't have happened if the issues with like the 1937 Stanford Binet weren't noticed, and people didn't want to see a change. IQ and index scores are highly reliable and valid, although caution should be used in interpreting the subtest scores. And there's strong correlations between older versions and between different versions of the WAIS, but that seems almost like cheating. I mean, if you want to know validity, you should be testing against other things. So hopefully, in more recent time, there's been more of this kind of thing and more validity measures on the WAIS. And if not, there should be, because just comparing it to an older version of itself doesn't seem to be quite enough. I think that's it. All right, so that wraps up both the sort of parts of intelligence. I got so theories of intelligence, and also sort of how at least 2 of the largest intelligence scales have been developed over time. And again, we could have gone into more in terms of looking closer into like Spearman's or Gardner's or whatever. But these are the 2 main intelligence scales that have been around since the turn of the last century, right? So at least the Stanford Binet has, and they're still widely used. So anything that's been around that long, yes, they've been revised, yes, they're sort of different than they used to be, is likely to have stood the test of time, and people continue to use it because it actually works and is reliable. So that's it. That wraps up intelligence. I hope that you have a better understanding of sort of how IQ is measured and how complicated it is, and how it's defined, and why it has sort of driven these tests to be as complicated as they are.